So yeah, if the condition is true, there is a code. If the condition is false, it comes through this part. So let's say, for example, I've declared my name as a string like Yeti, and I'm checking the type of my name. Remember when you check the type, it returns the class for you. So I want to verify, if the type of this variable is a string. So I said if, the type is a string. So the equal here is a logical operator. Remember the assignment operator. So this is a logical operator. So this is just saying if what is on the left side is equal to what is on the right side, then print this statement. So as long as this type name is a string, it will print this. So let's say this is 5, like it's a number. You can see that nothing is printed because there is no else condition to when this first condition is not met. Now let's move to this, right? This is what I actually showed you. So if it is a float or whatever that is not a string, you can see like nothing is printed. Now let's look at how we can solve this, right? Or how we can extend this. So I've declared a number to be 20, and I'm saying when I divide, remember the modulo is remainder. So I'm saying when I divide the number n by 3 and the remainder is 0, then I want to print that is an even number, because we know that every time we divide something and it does not give us a remainder, then it is an even number. So you can see that because it is not, because 3 is not an even number, it's going to skip that. But I have this other code that is here that is not even related to this. So regardless of whatever happened here, I want to print this statement. So that's just a simple if statement. Now let's look at how else statement works. So in else statement, I have an expression and I'm saying if it is true, implement this. However, if it is false, implement this. So I have given another condition for when it is false, unlike here when there was no condition for that. Now, the same thing I've done here, I'm now introducing the else keyword. So here I'm saying if, this number is divisible by 2, make it, print an even number, and we know that this is an even number, right? But once we change this to 21, for instance, we know that the remainder is not 0, so it prints an odd number. So this is a typical case of if and else. So it's not just the if, but when that if statement is not fulfilled, there is an else statement that also does something. Now the if elif else statements, this is an expression, right? And if it is true, we implement some condition. If it is false, then we test again. If it is false, for instance, we have another expression on that. So let's say I'm trying to log in. So I've logged in, my credentials, are they matching? No, false. So if they are not matching, then the condition is that I want to tell them that they are not matching, and then I'm giving them another chance to type their password again. If it is false, like, this same second condition that I'm giving them, is not matching, then it is false, then I am implementing this body. Or let me give another example. Are my credentials matching? No. So that's false. Then I ask, let's say the program takes you to a page where it asks you, okay, what is your your security question, right? So that we can know that if it is really you that is trying to sign in. So in this security question, right, I am now saying, this security question, is it true? Like what they have given me, like I've said, okay, what's your mother's maiden name, right? And what they have given me still is wrong. So that means that is false. So I'm saying, okay, well, you just have to reset your password. But if it is true, then I said, oh, okay, since, they know their security password, then I say, okay, you can just log in. So that's just an instance. I know, like, for security reasons, you barely find that happen. And that's exactly what we have here. I have declared the number and I'm checking if the number is less than 0. So we know that this number is not less than 0. And then I'm now saying, Well, if the number is less than 0, print that it is a negative number, because we know that anything less than 0 is negative. Else, if that number is equals to 0, I want you to say that the number is 0. Else, so it means the number is not less, the number is not less than 0. The number is not equals to 0. So definitely it is a positive number. So this is where if else comes in. So you can see that we are controlling the flow of our program. So these are another typical example. So you may wonder, can we have just one else statement? Actually, no. You can have multiple statements. So I'm not going to explain this side. I just want you to think about this, given what I've explained here. Go over the code and try to, get it yourself. Now, nested if. I know we are like going deep. Nested if means that I have unlike here where, this if is standing alone, and then we say, if this is not met, come here. If this is not met, come here. If this is not met, then come here. In this case, when we say, is this condition met, we now have another condition inside the condition. And you can have many nested ifs, to be honest, but I mean, in terms of good practice, it's not good to write codes. It means there's just some adjustment you need to make to your code. But this is what nested if is. It's like, okay, if the user is able to sign in, then check again if their security question is right, then check again if their some other security pass is right, then allow them to log in. And then you can see that I can also start from here and say, is their credentials right? Yes. Is their security password correct? No. Then it comes to this else, because they are in the same indentation. And then I say, okay, since their security password is not correct in this, even though this is the password is correct, but their security password is not correct here, else then tell them that their password, the security is not correct. And if we look at this level, if their security password, their credentials is false, then what that means is that, well, we cannot allow them to even go to the security question stage. It means that, well, they need to be, they need to reset their password or something. So this is what that looks like. You can see I have a number 205. I check if the number is less than or equal to 200. So definitely this number is not less than or equal to 200. So where do you think it will come? It will come here, because this first condition that should even take us deeper into the nested if is not fulfilled. So it's just tell you that, the number is greater than 200. But let's say I put the number 200 here. You can see then, because it is less or equal to 200, then it tells me, well, the number is less than or equal to 200, and it then proceeds to this next stage. Is this number a multiple of 3? Well, if it is, print. Else, if it is multiple of 5, print. Else, if it is not a multiple of 3, that is, it's not fulfilling this condition, then it is not a multiple of 3 or 5. So I want you to think of a number that can help us to print this. Yeah, I want you to think of a number that would get this nested if to actually print this value. So let's move on. In the last module of this section, we are going to look at repetition, which is also a control flow. We have two types of repetition. We have the while loop and the for loop. The while loop is, this people get really confused here, but I can tell you that it's very simple. The while loop is basically a condition that is repeated until the particular condition is true. While that particular condition is true, it will keep executing that piece of code. The control flow is that it will execute that flow of code. So for example, I can say while it is raining, set the thermostat of my house to be 25 degree. So once, of course, let's say there's a sensor that is making me know if there is raining or not. I've set, that control flow to be like that. So what that means is that while the temperature of my house, actually, this is what we use in my current home, because I live in the UK. So when our thermostat, when it is less than, 20, I think 21 degree or 20 degree, the heater in the house is going to come on. So that's the while condition. So as long as our temperature in the house is less than 20 degrees, the heater in the house is going to be on. But once that condition becomes false, that is, it goes to like 20.5 or 21 degree, then the condition is no longer going to be valid, because now it is no longer true. That is basically what the while loop is for. It is repeated until the condition is met. And we are going to see an example. So I have a count. So I've set a variable and I set it to be 0. And I'm saying while the count, that is the first value here is 0, right, is less or equal to 3, I want you to always print count, and I want you to add 1 to count. So we start with 0, right? And I say while 0 is less or equal to 3. Well, it is. So it prints 0, and then it say count is equal to what? Is 0, which is the first value, plus 1. So count becomes 1. So it keeps going again. Okay, now that count is 1, you see, is it still less or equal to 3? Well, 1 is less or equal to 3, right? So it prints 1, and then it says count is equal to what? 1 plus 1, 2. It goes again. Wow, 2 is less than 3, yes. So count because what? 2 plus 1, which is 3. Is 3 less or equal to? Because of that equal sign, yes. And then it increases it. By the time it comes here and say 3 plus 1, 4, and it comes to this while 4, well, now is false. So the piece of code is no longer running. And that's why when we print it, we can see that it stops at 3. Now we have what we call infinite loop. I'm not going to, we have what we call infinite loop. And when you look at this code, it means while 0 is less than 5, print I. Infinite loop is a loop where when you comment, I want you to comment this code, because now we are not going to increase I. So it means when it says while 0 is less than 5, print 0. So because we are not changing the value of I, this will become an infinite loop. Yes. So I don't want to run it, because when we run an infinite loops, the cell just keeps running and the code never stops until you forcefully, shut it down like this. You shut it down. So, but I want you to comment this out and try it. As an exercise, I'm going to allow you go through this code, and I want you to play around with the code to understand how this loop works. So I'm just leaving this as an exercise for you. And like I mentioned, we have the infinite loop, and this is an example. As you see here, I'm checking when the number 10 is equals to 10. So this will always be true. So it will continuously print norm is 10, norm is 10, norm is 10, until we forcefully, stop the cell from running. So this is another example of infinite loop, but I'm not going to run it anyway. So can we use if else in a while loop? Yes, we can. And this is a typical example that I'm also going to leave to you to go through.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
Now let's look at the for loop. For the for loop, it is a condition that we use when we need to iterate through a set of fixed value. What do we mean by that? So a typical example can be, let's say I have gotten 5 packs of spaghetti. Remember, it's 5 packs, right? It's just 5 packs of spaghetti. So let's say I have a robot in my house that cooks for me and it knows where the spaghetti are. A for loop is can come into place where I say, for as long as there is spaghetti inside my cupboard, cook spaghetti on Fridays. So the for loop has a fixed termination. The termination for a for loop is that I have set a particular limit and I'm saying I want you to cook 5 spaghetti per week. And once you get to 5 spaghetti, don't cook spaghetti again. So let's say I could actually have 10 spaghettis, but I'm telling the robot the condition is that once you get to number 5 spaghetti, that should be the last time that you cook spaghetti for me in the house. I don't want you to exhaust the remaining spaghetti. So this is what a for loop, is used for. So you can see we have a condition, and as long as that condition is true, the conditional code is met, and it goes back again. It checks that the condition is still true. So what we make my condition false is in this example is when the spaghetti that has been cooked that is now number 5, or is the 5th time that spaghetti is being cooked. So remember I said is a list, like is a fixed thing. So we are going to use a list with a for loop now. So I have weathers, right? And I have a list of the weather that we have in the UK. For instance, we have the fall, summer, winter, spring. How we really create a for loop is the syntax for weather in weathers. So I'm going to explain. What is here is a placeholder. It can be anything. However, when I want to make use of each element of this list, I have to use that keyword. So I could actually say for W in W. But I cannot say for W and then I come here and I type for weather, because what is weather here? You can see it doesn't know what weather is. Right. So if I say for W in W and I come and say, okay, print each element, right? So it goes through the first one, the second one, the third one. By the time it gets to the end, it stops. So in for loop, it is fixed. Remember that in while loop there's nothing fixed, is that a condition is met. But the condition here, a condition is also met here, but the condition is always by default by when the loop has exhausted the fixed condition that we have given it. So we are saying for every element in weather, print the element for me. So this weather is fixed because we have just 4 elements there. A list will always have, even though it's 1,000, it will go through each of it. And by the time it gets to the 1,000th item, the loop is going to stop because it's fixed. It has not gotten to the end. So, but let's return this back to weather. Like I said, it's just a placeholder. And you can see that we are back to this. We can also use, a for loop with a set, like we see here. We can use it with a tuple. So this is just snack. And here you can see I'm combining, the string formatting that I showed you in the early course. So I'm saying for each of the snacks that I love, just tell me that I love it. Can we use for loop with a string? Yes. Remember that so this is something that I also want to show you, that for a string, you can actually index a string the same way that we index a list. And if you print it, you can I want you to go through this and just explore what we've done there. So this is just me looping through each character in a string. So I'm showing you how for loop is used with the different data structures that we have and the data type that we have. And finally, for a for loop, we also have this range. A range is a function that actually takes in 3 parameters. It returns a generated list of integers from a lower bound to an upper bound. So we can declare a range in 3 ways. When we put a value here, it means that that's the value that it should stop. Remember I said a for loop works with a fixed range. It works with a fixed value, a fixed range. And the range stop, it means that I want you to stop when you get to number 4. However, just like we have in indexing where the index starts from 0, the X value will start from 0 here as well. And it will print it up until number 4. Like it will print the number you have put there. So it's like the number there minus 1, but it will print 4 times. Now we can also add a start. So let's say I don't want to start from 0. I want to start from number 4. So it's just print number 2 and then number 3. So let's just print that. And if you print a range, you can see that it just tells you, 0 to 7. And this is where we have like a starting parameter, like I showed you earlier. I want it to start from number 3 and to print 3, 4, 5, 6, as you see here. So the last item here will never be printed. Now we are going to see this where we had the step. So here, we go one by one, but we can actually add the last argument as steps. So here we say start from number 2 and print up until 9. We know that this is not 10, and take 2 steps. So it starts from 2, 3, 4. That's 2 steps. From 4, it takes another 2 steps. 5, 6, yeah, and from 6 it takes another 2 steps. 7, 8, and because of course this is 9 in a sense, it stops at 8. And you can see here I just changed the value, start from 0. Here you can also explore this. This also shows us how we can use for loop with dictionaries. You can see here that when I do for X in my dicts, it just prints, the key value for me. That's his name, age, favorite food. And of course, we know this from the, the last section. If I want to print, another way to print just the keys is by doing dot keys. So even if you don't do dot keys here, you can see that if you just do my dictionary, it just prints the key values. But if you also just want to use dot keys, you can also print that way. If you want to print the value, you use, dot values, which is what we have here. So this is just showing you, how we use a for loop to print. And there is also the my dictionary.items, and what that does is that it allows us to print both the key and the value at the same time, and we do that using the dot items. And you can see here, rather than using one value, we are using key and value. And once you do that, by default it will print the relevant key and the value. So you can see the key is name and the value is Yeti. Yes, I'm going to leave this to you to also explore how we do, if else in a for loop. For instance, I'll allow you to go through this code, but it's actually quite very easy to do. Here I'm showing you how you can combine with a tuple, how you can look through a tuple and actually have a conditional statement in a for loop. So here I have a number, these numbers of tuple, and I can say, okay, for each item in this number, check if the item is not divisible by 2, and then add for every of those items, add them. So let's just look at that first. So you can see that for every item that is not divisible by 2, which is 5, 9, just 5 and 9, it's first of all print 5, and then it's adding, I'm saying add 0.5 to that number. So and as a bonus course, I want to show you list comprehension. I've been showing you how you've looped through a for loop. However, now I want to show you how you can still perform certain operations in a list without using a for loop. So for example, let's say, I'm going through this and I want to extract just the fruits that have the word A inside it. So we have apple, banana, and mango. I want to get rid of any other fruits that does not have the letter A. So I go through each of them. I've created a new empty list, right? So I go through each of them and I say, okay, if the character A is in X, remember that X here now is like each item. So if A is in apple, if A is in banana, if A is in, it goes through each of them. And I'm saying, okay, append such fruits, which is X, to that new list. And I'm printing the new list. I have done the same thing using a list comprehension. For a list comprehension, it's quite easy. I say for X, so I say X, that is each item for each of those items in this, if A in X. So let's read it this way. Go through, so let's start from the for loop. For X in, you can see it here. For X, in fruits, check if, we are basically, you can see that everything I've written here is what I've brought here. Check if A is in that X and then extract the X. So instead of going through this for loop and writing if, and then I'm not creating a new list where I'm not saying dot append and all that, I can just create that list and write this code, and I would expect that it's going to do the same thing. So that's why we call it list comprehension, because we are not writing these long lines. You may want to ask, is list comprehension faster? Well, not necessarily. It's not like it's faster. It just makes your code, more readable. And I've done the same thing here. I would like you to study this. I've replicated what I've done above in this list, but I would want you to write the list comprehension for this code. Just look at how I've, taught you here and replicate the same thing. Yep, you can see this is also another kind of list comprehension, but in this case, adding a new condition that is not modulo. I'm just saying if X is not apple, and I want you to write the list comprehension for that as well, although I've written it, but make sure that you at least write it yourself and check if the code is correct with mine. Well, we have come to the end of this course, and I hope you really enjoyed this. I hope you now have a good, safe landing with Python. I hope you are now confident to explore your Python skills. I have some other courses that I have done on Python libraries, diving deeper into, how these Python libraries can be used in data analysis, in data science, like the NumPy, the Pandas, and the visualization courses. So I'll advise you check that out if you are interested in exploring your Python skills in the data field. Then you would want to take that course. And please share this course with your friends, with your families, with your colleagues, with anyone that you think would benefit from this. And bye, and all the very best with your career choice. I also have a data community, and if you check my Instagram bio, you're going to see the link to join my community there. It's a community of vibrant data experts. We have data analysts, we have data engineers, we have, different kind of data fields, and we have people who are new. At every time we have new people who are just getting started, and we've seen people who are novice becoming, experts in their fields. I also started as a novice, and here I am years later. So I'm rooting for you, and I hope to see you in my community. Take care and bye.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing.